Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazeeq bin HUSNI alias ZAMRUD with metric number 1810501. Today, I'm going to talk about my final year project 1 presentation titled Performance Characteristic of Indium Gallium Nitride Light-Emitting Diode. First of all, before we go any further, this is my presentation outline. I will talk about some application of InGaN LED, the problem statement, objectives, some literature review, table of summary of previous work, the methodology or the procedure on how to obtain the objective of this FYP, the preliminary result, conclusion, and finally the Gantt chart for my FYP2. Okay, now let us see the application of InGaN LED. As you can see from the picture on the left, it is being used for growing plant in space. We know that all plants require lights for photosynthesis. Therefore, the LED are acting as the sun, which will give the plant the source of light, because this is the basic need for the photosynthesis. Okay, next for the second picture, this is the space station shut-eye. This lamp helps astronauts to sleep in peace because it offers more efficient, longer-lasting lighting option, as well as providing the crew member the ability to adjust the lighting intensity based on the time of the day. Okay, this is the problem statement of my FYP. High demand of commercial gallium nitride or indium gallium nitride LEDs as lighting source in space, military, and extreme industrial environment. Thus, it is important to study about performance characteristic of indium gallium nitride LEDs and better understanding about the electrical and optical performance due to varying temperature and increasing injection current. This is because there may come a point at which commercial InGaN LEDs are no longer viable, as well as to advance the development of commercial InGaN LEDs. As a result, by better understanding the characteristics of this LED, the technology can be improved. Okay, let's see the objectives one by one. The first objective of this FYP is investigate the current voltage measurement of indium gallium nitride light-emitting diode with varying temperature range from 100 Kelvin to 500 Kelvin. The second objective is investigate the electroluminescence properties of InGaN light-emitting diode with increasing injection current range from 0.1 milliampere to 10 milliampere. And the last objective of this FYP is to analyze both the electrical and optical result with various models of InGaN light-emitting diode. Now, for the next part of this presentation, I will briefly talk about the literature review. First of all, we need to understand how semiconductor work. A semiconductor has p-n junction. In p-n junction, there are p-type material, n-type material, and in the middle between them is depletion region. Okay, this p-n junction can be in three states: zero applied bias, forward bias, and reverse bias. Zero applied bias occurs whenever the current present and no external stimulation is given to the p-n junction, which is in the thermal equilibrium state. For the forward bias, the positive terminal voltage source is attached to the p-type material, while the negative terminal source is attached to the n-type material, causing the size of the depletion region shrink. And the last condition is reverse bias. Reverse bias whenever a positive voltage applies to the n-type material and negative voltage is applied to the p-type material, which make the depletion region grows. Okay, for the next part is current voltage characteristic of indium gallium nitride with varying temperature. As you can see, these are the graphs which are expected for me to get when finished with the experiment, the forward bias graph and the reverse bias graph. As you can see from the graph, when the temperature rise, the voltage is dropped. Okay, this is the optical parts of the experiment. The electroluminescence of InGaN LED with increasing injection current. Okay, this experiment has been done with injection current range from 0.1 milliampere to 10 milliampere. As you can see from the graph electroluminescent intensity spectra of white InGaN LEDs, okay, when the injection current differ, it will affect the light intensity and the wavelength of the InGaN LEDs. Okay, this is the table of summary of previous work. I have compiled some of them to put in my presentation. As you can see from the title itself, it's clearly said what they are focusing about. Some of them are temperature dependence of performance InGaN with multiple quantum well, some of them with temperature dependent characteristic, and also temperature dependent electroluminescence. They all has a different Kelvin, and I have put the different in the remark section here. Okay, this is the flowchart of methodology for my final year project. First of all, I start off with reading some literature review and collecting data to gain some knowledge about what the topic of my FYP is about. And then in chapter 3 is the experiment setup or the methodology on how can I achieve my objective. There are two parts in my experimental setup, which is the electrical setup and optical setup. For electrical setup, I use Catley 4200 ACS parameter to get the current voltage measurement, and in electrical setup, for electroluminescence measurement, I'm using the Horiba IH320. This experiment will be conducted in IIUM. And then after getting the result from both the setup, both experiments, I will analyze of the result and do some discussion in chapter 4 for FYP2. Finally, final report writing and finish. This is the preliminary result which I get from doing the electrical experimental parts. So I've done for one company, which is model SLX LX3054 UWC from Lumex, to get the forward bias and reverse bias. To get this graph, I need to use a Sigma plotter software to plot this type of graph. Okay, in conclusion, it is important to study about the performance characteristic of indium gallium nitride light-emitting diode in order to obtain the objective or the goal of my FYP. And then, by studying this, we can help to improve the development of LEDs with nitride base. Okay, this is the Gantt chart of my final year project 2 of what I am planning to do in the upcoming semester. With this, I end the presentation. Thank you for watching.